Okay, there we go. Okay, great. Let's get started. Your first
Okay.
task will be converting an implementation of the try data structure from Java to Python. And you'll do this one with AI support.
Right.
Your second task will be converting an implementation of the priority queue data structure from Java to Python, and you'll do this one without AI support. We'll also
Okay.
take a short break between the two tasks, since this session will take about 2 hours. First, let me tell you a bit more about this code translation task. The task is to produce a complete and working Python translation within 30 minutes. By complete, I mean that all of the functionality and documentation from the Java code should be translated. And by working, I mean the Python code should be tested for correctness. We're not providing you with tests, but you can write some informal tests to exercise the interfaces and make sure it's doing the right thing if you get that far. As I mentioned earlier, there's more work to do or accomplish to accomplish an absolutely perfect translation than what can be done within 30 minutes. So really, I'm asking you to just do as much as you can in that time. But there may be trade-offs in how you spend your time, such as whether you choose to translate all of the functionality first or translate a portion of it while testing it to make sure it works. How you navigate this trade-off is completely up to you.
Okay.
All right. A few other things we should mention. There's a lot here. You'll be using an online version of the VS Code editor in this study, which is a few minor differences from the desktop app, which you're probably familiar with.
Yeah.
In general, all the menu commands and keystrokes are available and should just work, but do let me know if you encounter any difficulties. I won't be able to answer any technical questions about the code or what it's supposed to do, but I can tell you that the Java implementation is correct. Almost true. When you make the translation, please try to preserve the naming of class and method names, but we're less concerned about how you name the variables.
Okay.
You can also use whatever resources you feel would be helpful, such as searching the web or Stack Overflow or running any code, since we've installed Java and Python in the editor. I'll give you a 5-minute warning when the time is almost up so you can know to start wrapping up your work. We also ask that as you work on the task, you think out loud and tell us about what you're thinking and what you're doing. This really helps us understand how you're approaching the task and what you're thinking about as you do it. If you're quiet, I'll remind you to keep thinking out loud.
Cool.
Do you have any questions before we get started?
No, it all sounds good.
Okay, so why don't you share your screen and want to make sure.
Just thinking I'll probably do this on my laptop screen, so I'm just going to turn a little bit. Otherwise, it'll be a 4K and you'll have tiny text all over the place.
Right. If the screen is super high resolution, we may have to, make some adjustments so that the recording captures and I can see what you're doing.
No, that's fine. I've put it on my normal one, so that should be all right.
Okay. All right. You need to be in the VPN. Are you inside the?
Yeah, I'm on Europe at the moment. Is that okay?
Yeah, that should be fine.
Cool.
And what browser are you planning to use?
Is Chrome okay?
Yeah, Chrome is great.
Cool.
All right. So in this task, you'll translate the try data structure from Java to Python with the help of the AI code translation system. This system is able to automatically translate code from Java to Python, but it's not a perfect system. And so the translated code may contain errors in it.
Right.
We've used the system ahead of time to create a Python translation for you, which you'll see when you open the editor. Now, how you use this translation to help you complete the task is entirely up to you. And some people copy and paste the whole thing. Some people just use it as a reference, that sort of thing.
Yeah.
And I'm going to give you a link now to the first task. I'm putting this in the chat.
Cool. Okay.
All right.
Cool.
So let's see, can I see that? Yeah, I can read it.
Is that all okay? Yeah.
Yeah. All right. So there's a Java file a Python file and an AI file, an AI Python file.
Gotcha.
So,
Okay.
right. And if you want to do any kind of like side-by-side thing, there's a little split screen icon in the upper right-hand corner.
Oh
Which
yeah.
might be convenient. And we can start the timer now.
Okay.
All right, starting now.
Cool. I will talk to myself. I'll just have a quick read through all the documentation first, if that's okay.
That's absolutely okay.
Cool. Object for storing and retrieval of strings. Basically builds a tree of nodes where each node represents a character in a string that's been stored in the tree. A stored string is represented by a path illustration route to a node marked as an end of word node. Okay. A class is used by children to store individual nodes in the tree. Each node is points to a thing. Okay, so children is word is node. Children is end of word. Set end of word. Okay. Tree node. Insert. So string into the tree. Is it pronounced tree or tray?
I happen to be a student of the guy who invented this in like in the 60s, and he pronounced it tree.
Tree.
But most people these days pronounce it try, at least
Fair enough.
at least around these parts. Mostly to distinguish it from, generic trees.
Yeah, definitely.
So,
Okay, cool.
yeah, so I never know how to pronounce it when I speak to people.
As long as I'm not butchering it for your recording, that's fine.
That's fine.
Test whether a string is stored in a tree. Fine. So it's the word length for each character in the word. Get the children a character. If the node is null, return false. Otherwise, return the node. Okay, cool. Return current is end of word. Remove a string stored in the tree. Recursive delete method. So that just calls that. Index word.length. End of word. Set end of word. Should delete. Enumerate through the list. There's a function to enumerate strings stored in the tree. If current is at end of word. Pass the node. Get the current node is end of word. Entries.add. Entries.toString. Current get children. Okay. Right. Okay. It's created a tree class, and that's created a tree class. And then it's created another class there, the tree node. It starts with that. So have children is word. And that's a hash map, so yeah, dict, that's fine. Public tree node. Just initializing, yeah. Get children. Return self.children. Yeah. Is end of word. Return is end of word. Is word. Return is word, yeah. Set end of word. End of word. Self.is is word. Okay, cool. And is that the right? The tree node class is used by the tree to store. Okay. So that's all in there. That's probably fine. So I'm just thinking. So sorry, I need to talk to myself. So I'm just looking at the fact that the class is Java is slightly different from Python. So the tree node class is defined first. That's fine. Right. So when we start off, we create a root, which is a new tree node. Yeah. And then we insert. Let's have a look at that. So current is self.root. Yeah. Now for L in Word. Yeah. That would work. Current equals current dot get children dot set default. Ooh, okay, all right. Current dot get children. Current self dot root. That's a tree node, and that's saying get children set default. Children's a dict. Okay, so this is new to me. I've been writing Python for the last 7 days or 5 days, and I have not seen set default on a dict. So I'm just going to have a Google for that. Python 3 dict set default. Method is similar to get, but will set the dict key default key if not already in the dict. Okay. So key name of the item you want to return. I haven't. Wait. An X. Car.set default. X equals car set default Y. Okay. But what if you did print car? I might have just learned something brand new about this language. That's oh my god. Okay, that's cool. Right. Okay. Nice. That's clever. So it's basically saying if this key doesn't already exist, then set the default of that key to this. So it's basically saying for each character in the word, set that child, that key within that to be an empty tuple. Okay. Right. I might just write some code in here.
Okay. You are writing in the AI file at this point.
Thank you. Thank you very much. I appreciate that. Let's just fix that. Probably just going to copy it all over. Just
right.
Because it's already the AI already seems to know more about Python than I do. So here we were. So each character within child to an empty tuple. Right, so is that actually what this thinks it's doing? So I just want to be clean up. Basically, I'm trying to go through, work out what the Java's trying to do, what the AI version thinks it's done, and just see whether it's doing the same thing. So compute if absent, that's a bit more explicit, and it's basically doing the same thing. Okay, so it's saying for each character in the word, do that. Cool. Current.set end of word, true. Okay. Right. So I'm just going to storing and retrieval of strings, builds a tree of node where each node represents a character in a string that has been stored in the tree. A stored string is represented by a path in the tree from the root to a node marked as end of word node. Interesting. Right, find. Let's see how this would work. So we provide it with a word, current is self.root. Yeah, I think that would work. For character in word. Yeah. Node equals current dot get children dot get character. Now get children provides us with a dict. So that should work. If node is none, return false. Yep. Current equals node. Current is at end of word. Seems right as well. I'm sure there's going to be something here that's going to trip me up. Delete self word. Remove string stored in a tree. Oh, interesting. What's there? Okay. So it's missed that documentation for insert. So I'll just add that in. See how it's doing it for everything else. It's doing it a little bit differently in places. So it's done the documentation for each function has been done slightly differently. How do I normally do it? I kind of just normally write them out. So word insert string to be in the right place. Word the string to be inserted. I know I could probably copy and paste a lot of this stuff, but I find normally when I'm trying to learn code, I'll type it out. I don't know if this works for everybody, but actually typing it sort of embeds it in my brain a bit more. Right, so now I've realized that some of the documentation's off. I'm going to go back and look at that. So inserts there. In it, yeah, it's just a constructor. So have a look at the tree node. Tree node does not have any documentation on those functions. So that's fine. Okay, let's carry on. So find. Right, so word. It's not actually asking for the word we want to find, I guess. P-R-E. And then, yeah, never know. Right. Returns true if the string is stored in the TRE, false otherwise. A little space between those. Current fruit, 4-character word. Okay, yeah, I think I've done that. That's fine. Delete. Right, it's done it a little bit differently. Word. Delete. Delete root word. os.path. Okay. Okay, this looks like it's done something a little bit weird. So it's trying to do an OS path join. That's not going to work. It wants us to it's just calling out to the function below. Delete. So yeah, current word index. So that's wrong. So we just want it to be delete root self.root word and 0 is the index. That doesn't need to be there. Have I missed anything else? So, okay, so it's the AI has forgotten to reference self.root as well in places. So I'll have to go through and have a quick look for that in a minute. Okay, so delete. Let's see how delete actually works. So we've got current node, word, the string to be deleted. Again, added some spaces in there. Well, it can't be if you just use the string to be deleted. Index the current depth that we've descended. Double spaces are annoying me. And then we're going to return something at the end. So get returns true if the string was deleted, false if it was not found. There we go. Right, so just make sure we get the same things. So we've got current word and index, as well as self. It's good. So if index is equal to the length of word, if not current, end of word. So if not current is end of word. Cool. Return false. Yeah. Current dot set end of word false. Yeah. Return current dot get children dot is empty. Is empty of array. Hang on. Children is a dict, so it's not an empty array. Now size of a dict. Python 3 number of keys in dict. I think it's length, but I'll double check. Yes, I can use len. So return len length of dict equals 0. So actually, is dict empty? Boolean evaluation of the dictionary. Yeah, length. That'll do. Oh, don't stop sharing. Cool. Okay, so it got that a little bit wrong, but that should be fine. Return length current got children. I like wrapping things in parentheses if I can. Character. So character equals word try index. So yes, that should be fine. Node equals current dot get children dot get or none. Okay. If node is none, return false. Yep. And then it says should delete current node equals. That's making it. Okay. What's going on here then? So it should be doing should delete current node equals delete node word index +1 and node is not at the end of word. Okay. So this is trying to do. It's trying to make a tuple of size 1 saying self.delete node word index +1 and not node is at end of word. So I don't think we need those brackets. Self.delete and node is end of word. Yeah, okay. If should delete current node, current dot get children dot pop. No, because get children's a dictionary. Trying to rack my brain is do I know exactly how this works, or is this yet more stuff about Python I don't understand? Python, that's a list thing. No, it's not. E and the default. Okay, cool. Well, there we go. That's fine. Return current dot get children equals empty list. Again, that's saying it's not an empty list because it's a dict. So current dot get children. I think at least. Right. Enumerate. Look at this. Enumerate the strings stored in the tree. Again, missing a return. Returns a list of strings that are in the tree. So create a list. Yeah, and then enumerate new string root entries. Okay. So this is saying root for root does files and os.org. Okay. Whoa. What is it? What is it trying to do here? This is okay. It's just calling enumerate on new string builder. Right, okay. I'm just going to start writing what I think it should be, and then, yeah. So entries I know is fine, because we just want an empty list, and then we want to call the enumerate function on that list of entries. Okay. Right, so actually what we want to say is entries equals... again, can we do that? Can we create... Entries, it's expecting an entry, node and entries. Entry, the current state of the string we're reading out of the tree. So in this case, the current state of the string we're reading out of the tree. Okay. So where's it using entry? Entry.toString, entry.append, character key, entry, delete chart. So okay, so it's just expecting a string. Okay, so because we want to enumerate everything, we just give it nothing. And then we give it the node, which is self.root, I think. Oh no, that's self. Where's the node coming from? Oh no, it's self. So self.root and then entries. Don't know whether you can you do that, define that, and then pass it in and then return it. Just going to leave a note for myself because I'm not sure whether that would actually work. It might be that I'd actually want to just return entries from the enumerate function. I mean, okay. So I really don't think any of that's right, so that can go away. Enumerate, right. Recursive function to enumerate strings stored in the tree. And we want to say we're looking for entry, current state, what is the string we're reading out of the... Been spoiled by big screens. Node equals the current node that we're visiting tree. And then we return, oh no, there's another parameter, entries, the list of strings we found in the tree so far. Okay. Right, so current equals node. If current is end of word, then entries.add entry, yeah, because that's a string. Object keys, so keys current.getChildren.keys. That's fine. Keys.sort, yeah. Then for key and keys, entry.append, sure. Yeah, return the Unicode string of one character. Okay, cool. Then self.enumerate. Good point. Self.enumerate. Entry current.getChildren key entries. Entry dot, yeah, pop, that's fine. Merge another tree into this one. So takes the other tree, it enumerates that into its entries, and then for entry and entry, we insert it. Okay, cool. So other tree, the TRIE to be merged in. And yeah, so for
It's your 5-minute warning.
okay, cool.
5-minute flip.
Thank you. Save my work. Let's just check that as well. So the tree class, here we go. Tree node class A is word flag. Okay, I don't think that's important. I should actually try and make a test that tests this. So test. There we go. So tree node entry. So from TRIE import tree node. And okay, let's create a new. So my TRIE equals TRI. So it's normally capitalize a class, at least I would. I'm just going to do that. That TRIE. So create a new tree. So then let's give it a try. So say my TRIE dot insert hello. And is that the way you run it? Yeah, cool.
That's the way you run
it. Okay, cool. Right. Got an error. That's good. Self.root equals tree node. Tree node is not defined. Of course, because I've gone through now and put. Okay. So yeah, probably shouldn't have done that, but okay. Right. Okay. Current.getChildren set default. Right. Here we go. Okay. So line 48. Tuple object has no attribute get children. Current does not. Current equals current.get children. Okay. Where am I doing this in insert? So what does that return? Set default is tuple object and no attribute get children because I'm returning that. Right. I think I just want to. Did that change it? So it's returning, yeah, because it's returning set default. Oh, don't want this. I don't think I'm going to get it to run. It's going to be a shame. Python dict set default. Returns the value of the item with the specified key. So current equals self.root for L in word. Current.get children. So it's expecting a tree set default. So I don't want that output. I think. Current.set end of word. That's returning a tuple. What does this return? That's what I should be looking at. Compute if absent. So current is self.root. Self.root is a tree node. So children is a dictionary. Get children. So yeah, okay, right.
Time's up.
Okay.
You did
Oh.
great. That's terrific. Really, really helpful and good thinking aloud, by the way. Didn't have to
Good.
prompt you at all. So the last thing you did was you were looking up compute if absent. I missed that.
I was working backwards, trying to look at how the get children set default stuff was working. See, I wanted to see what if compute if absent was supposed to
That
do.
was terrific. All right.
Whew.
Okay. Take a breath. You did really, really well. Yeah, lots of folks didn't get nearly that far. So I'm going to share with you another link, and this link will be to a survey. All right.
Cool. Yeah.
And you can talk through that as well. Get that up on the screen. And okay, you are P19.
P19, so P19 like that.
Yes.
Cool. I'm guessing that was AI, and it's tree. Is that right?
Yes. Yes.
Cool. How mentally demanding was the task? Oh, wouldn't say it was actually that mentally demanding. It was just one of those. The time limit was the issue there. How
Sure.
hurried or rushed was the pace of the task? I think I actually found it quite fine. I think I'd like to think that if I had a bit more time, I would have gotten there.
I'm confident that you would have. You were doing great.
How successful were you in accomplishing what you were asked to do? Oh, it's hard to know. I'll put myself in the middle because I don't. Yeah, unless I felt like I was definitely getting there, so that's good. How hard did you have to work to accomplish your level of performance? Yeah, I'd say I was working quite hard. How insecure, discouraged, irritated, or stressed and annoyed were you? Or insecure a little bit. I wouldn't say I was stressed or irritated. Go for about 11 there. Please describe your overall approach for how you worked on this task and how you allocated your time across the different activities. Right, so sorry, my keyboard's really clicky. I hope you don't mind.
No, I can't even hear it.
Cool. So please describe your overall approach. So first, read through Java code and the comments. Then made sure that the Python roughly matched the same structure. Worked through the different functions and comments, documentation and comments. And then from the top, worked through each class and function to make sure it was valid Python. And then started looking at the actual functionality of each class and function. How you allocated your time, I'd say probably about 60%. About maybe 15%. Worked through the different functions, documentation. 10%. 60, 70, 85, that's 15. Yeah, about 15%. Could have probably spent more time on that, but yeah, I think that's right. To what extent do you feel you understand how the Java implementation of the data structure works? Definitely not 100%. I'd say somewhat. I should have tried actually running the Java as an example. So it worked. Example first. And the nature of this TRI was very new for me. Yeah, I'm going to have to go off and read all about this. I've never heard of it, but it sounds fascinating. How would you characterize the quality of the provided translations? Good. Acceptable.
Want something in between good and acceptable, it looks like.
Yeah. Say somewhere. Yeah, I'll write that down.
Okay, great.
Overall, the structure was great. I want type. Yeah, the structure was great, but there were just some places where you could tell it just completely went off the rails.
Those are exactly the words I used to describe that phenomenon.
So why are you walking a directory structure?
Yeah, right. What were you thinking?
Some documentation was missing. Sporadically. Yeah, it was an interesting one. You know, you'd have thought that all of the comments would have mapped fairly well because they have a fairly sort of well-defined structure, like it's a string, just copy it across. But yeah, that was a bit of an interesting one. Oh, and some of the class references were missing. Self. How did the quality of the translations match your expectations of what could be produced by an AI system? The quality. So I guess without trying to change my answer or influence my answer, can I ask sort of what level of AI this was? Is this like it's a trained system that's just been given examples of code and it's trying to convert them?
Yes.
Is that okay?
That's something like that.
Cool. Definitely better than I expected.
I can tell you more about it at the end of the
Yeah, I figured as much.
of all the survey.
To what extent did you feel the provided translations were useful? Yeah, they were quite good. Had errors, somewhat helped to complete the task, great deal. Helped you understand the original Java code. Somewhat, I think the errors got in the way of actually understanding. Taught you something new about Python? Definitely. I need to that default. It's very useful. Did you feel that the provided translations made your work in this task difficult versus easy? I'd say it definitely made it easier. It definitely made me faster. And did you feel the provided translations made your work versus of the best quality? Made your work of the worst versus the best? I'd say it definitely made my attempts better. What did you find most useful about the provided translations? The automatic generation of classes and functions, as well as the, to word it, sort of semi-usable code that was generated.
That's amazing.
Yeah, I think if I had linting on or something, you'd be able to burn through it because you'd immediately spot all of the places where it's just syntactically not correct. But yeah, it's still pretty good. What do you find least useful about the provided translations? Least useful. Least useful. Can I say nothing? I think everything
You
counted.
can say whatever you want.
Yeah, everything was useful. Were enough translations provided for you? I would have liked to see more translations. Provided with enough translations. I think I was provided with enough translations.
In some cases, we provided in different subjects with multiple attempts at translating the code by the AI, and where we tried different things in places. Like maybe it would have made that set default call differently in different places because it wasn't sure how to do it, that kind of thing.
Right. Okay. In that case, I'll go with yeah. It was one was good.
Right. A lot might be.
Actually, I suppose. Yeah, I suppose actually I would have liked to. Yeah, thank you. What is that okay that I've changed my mind on that, or
Yeah, that's of course.
I wasn't quite sure
trying to influence you. I was just people get to that question when they've only seen one and go, "What do you mean more translations?"
yeah, exactly. No, that's good. What additional information could we provide alongside the translations to make them more useful to you? Something what would have been useful, I think. Extra comments for more complex Python, say functions, but Python features. Maybe more comments. Actually, yeah, comments. Actually, just comments generally. Comments generally for more complex Python features. That would be useful. And comments of the Java code used to generate functions when it's not as readable.
Can I get some clarification on that? Are you looking for the AI to help explain the Java code that you're translating?
No, it was more for I think in this particular so I'm trying to find a good example. I think I'd probably say in places where we're working through the say here where it's enumerating and things like that. Actually, no, that's okay. Where was I thinking? There was one particular. It was the computer absent, actually.
Absent, right?
Sorry?
It was probably the computer absent, I'm guessing.
Yeah, that was it. So basically, just basically, it would be interesting if that was commented directly above to say, I've converted this line to this line or this function to this function.
Oh, I see. So drawing a correspondence.
Yeah, that's right. Yeah, I'll write that. So use comments of the Java code used to generate corresponding functions, corresponding code, I guess. Yeah, there we go.
Right, cool.
So to what extent would AI-supported code translation be helpful? Normal working conditions, yeah, it'd be pretty helpful. Moderately helpful, maybe. 'Cause, yeah, when under time pressure, very helpful. When working alone, yeah. When working on code that only I would use, yeah, it'd still be helpful. When working on code that my team members or other people would use, yeah, probably quite helpful. When working in a small team, yeah. When working in a large team, say less helpful for experimental or prototype code, because presumably if you're dealing with something quite complex, you want to really understand what's going on when you're converting it. And when working on production code, I'd say moderately helpful because you're still going to need to have someone go through it with a fine-tooth comb, probably. For what situations would AI-supported code translation be appropriate? When the code is used for a mission-critical application, e.g. healthcare, moderately appropriate. Presumably, you'd put it through for one of those applications, you put it through lots of other checks anyway, so it shouldn't really matter. When the code's correctness is important, slightly important because the code correctness was here and there. When the code's runtime performance is important, that could be interesting. I think that could be quite useful because it could uncover, the AI could pick more performance-based features potentially. When there is a large code base to translate, oh yeah, very important. Don't want to sit there translating millions of lines of Java. When the original code is written in a language with which I am unfamiliar, yeah, that'd be quite appropriate. And when the code needs to be translated to a language with which I am unfamiliar, very appropriate. But I think I'd caveat those last two, saying that you'd still probably need an understanding of the languages you're transferring to and from, because you could potentially end up in a situation where you've got something that it thinks is right but is completely incorrect. How useful would each of these kinds of AI models be for real code translation work? A model that requires you to fix one problem per 100,000 lines of code. Yeah, extremely useful. Per 10,000, yeah, I'd say very useful. One problem per 100 lines of code. And then I think when you're getting down to those, it's kind of, yeah, one problem for one line of code, you may as well get a monkey to do it. Next, any other feedback you'd like to share? I was very impressed by the quality of the converted code, even though it wasn't perfect. It was still a huge time saver. Yeah, it's the cutting out all of the waiting, sitting around trying to write, just all of the framework and scaffolding. It's kind of done all that for you, which is quite nice. Cool.
That was great. Thank you very much. Good thinking aloud. You get an A in thinking aloud for sure.
If you need me to tone it down, feel free to tell me.
No, it's perfect. It's really perfect. We'll be able to go back through the recording and annotate your survey with to make it more precise. We're right on schedule. You want to take 5 minutes? Just or I mean, we don't have to if you don't want to.
No. If I could just go get a little bit more water, if that's okay. All this talking.
All right, we'll take a couple minutes and we'll start test 2.
Cool, thank you. I'll be back in just a second.
Yeah, me too.
Thanks. Perfect.
You got back faster than me.
I was too curious. I had to look up trees.
Looking up the tree. Yeah, so he called it tree for retrieval.
Right. Okay.
Um, that's the origin of that. Yeah. Um, he was my bachelor's thesis advisor,
Oh
but
wow.
he developed this. I don't know, when I was like 3 years old or something. So
Yeah, it looks like was it 1950, 1959? No.
I thought it was like 61 or something like that.
Oh, 19, yeah, 1960.
Okay,
So
okay.
Edward Fredkin.
Fredkin, yeah.
Yeah, cool.
Yeah, he drove a car whose license plate was robot, spelled out robot on the license plate.
Very cool.
Okay, so let's go into task 2, which yeah, it's gonna be okay. So you make sure that that file is saved, your tree.py, and
Cool. I think that's all saved. Yeah.
I think it saves automatically, but I don't trust it.
No, good.
All right, so you can close that one up, and I will give you a new link. In this task, you'll translate the priority queue data structure from Java to Python, and you'll do this one without AI support. So aside from the fact that we're not giving the AI, it's the same kind of setup as before, and this is why we alternate the randomize the order that things happen, because you're sort of more comfortable with the situation by the second one, regardless of whether you get the AI first or second, and regardless of which task you're doing. Okay, so so you've got your Java and you put the results in priority queue like before. I'll start
Cool.
the timer now at 11:01.
Okay.
Sorry.
Cool. Right. Okay. So gonna start reading through priority queue. I think I've seen this before, but I'll read it just in case. Cool. Java codes implement a priority queue using an array list-based implementation of a binary heap. This class can be parameterized for any element class that supports comparable interface on itself. Okay. Priority queue allows one to store comparable elements and remove them in the order defined by the comparator. This implementation will remove the highest priority items first. Insertion and removal are O log n operations in terms of the number of items in this queue. Okay, so we've got a priority queue, extends comparable, creates the heap. Heap is a new array list. Insert an item into the priority queue, item to be inserted. Index equals heap.size, yep, heap.add item, while index is greater than 0. Parent index is index minus 1 divided by 2. Okay. Parent is the heap dot get parent index. If parent dot compare to item is so okay. Heap dot set parent index. Okay, right. Remove the highest priority item from the priority queue. Heap dot size. So swap the last item in for the first. Okay. Element is heap dot get 0. Heap.set 0, heap.get index, right, okay, yeah. And heap.remove index heapify. Propagate the last item to the proper place in the heap. Get the number of items in the priority queue. Yeah, it's fine. Yeah, is empty, is empty. Provide all the results in priority queue order. Saved heap results. Okay. Add the elements of a collection for priority queue. Restore a section of the heap to maintain heap properties. So you can go to the index, the point to work on. If the indicated point does not have the proper relation to its descendants, their values are swapped and the descendant is then processed recursively. Okay, I'm probably not going to ever get there, so I won't worry about that right now. Sorry if you can hear thumping downstairs. My partner's making some banana cake.
I'm not hearing anything, so we're fine.
Good, good. Right, so I'm going to create our priority queue class. Priority queue. And boom, 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 boom. Yeah, of course, yeah. Okay, right. Actually, you know what's just so Python code to implement a priority queue. Array list based implementation of a binary heap. Well, we can use that. Let's just copy that up, actually. More useful. This class can be parameterized for any element class that supports comparable interface on itself. Right, okay, so it's basically saying you can give it anything-ish as long as it's got comparable. Java comparable class. Interface and pose. Am I allowed to look at documentation, by the way?
Of course, yeah.
Cool.
Yeah, anything you want to look at, you can look at.
Nice. This arrays of objects and this interface can be sorted automatically by collections. That's right, so it's a Java thing. Okay. Right. So let's do that. Init. Self. And the first thing we're going to do is go self.heap. That's a list. Right, insert. So def insert self item, insert an item into priority queue. And we're going to say item is to be inserted. Right, so index equals self.heap. But it's a length. And then we're going to say self.heap dot append item. Okay, and while index is greater than 0, parent index is index -1 divided by 2. And so the parent is self.heap parent index. If parent.compare to item. Right, so I need to work out what that does. Compare to fastest compare to method. The ordering is referred to as the class natural, referred to as a natural comparison method. So how does it work? Compares the object with the specified object for order. Returns a negative integer 0 or a positive integer as this object is less than, equal to, or greater than the specified object. Right, so it returns a negative integer 0 or a positive integer as this object is less than. Right, okay, that's written weird. So negative integer for less than, 0 for equal to, and positive for greater than. So it's basically right. Okay, so but it depends what we're giving it, because we could be giving this anything. So you'd have to have a way of implementing the compare to and whatever you pass to it. So you have a class. Actually, is there anything similar in Python? Python comparable. To make classes comparable, you need to implement underscore LT and decorate the class with. Okay. So there is already this in Python. To automatically generate ordering operations from a single root operation. See if I'm tools that. Right. Okay. So assuming that whatever we have implements this, then that would work. This provides the rest of the comparison operators, so you don't have to write any of them yourself. Be aware the decorate. Okay. So Python 3 ordering. That basically means I can just do less than or greater than. Ooh, okay. So if parent, no, because I need to compare it to something else. So if parent.compare to item is greater than 0, so if parent is parent.compare to item is greater than 0, does that saying it's greater? I have to comment this, document this. Greater than specified object, and here it's saying if it's greater than 0. So if no, put it down. If the parent is greater than the item, so basically say if parent is greater than item, I think. I need to find an example to test this. Then heap.set parent index item. Okay. So self.heap parent index tools item, I think. And then heap.set index to the parent. Okay, right. So self.heap index parent. That should work. And then index equals parent index. Index equals parent index. And then we'll say else pass, no, return. So pass or break work. Break. Okay, that probably won't work first time, but we'll come back to that. Right, remove. So def remove self. Just remove the highest priority. Okay, so that's easy. Remove the highest priority item from the priority queue and return it. So returns the removed item. So first thing it's going to say is, I don't have to really worry about that because Python will just return none. So index is, okay, so that's swap the last item in for the first, dot size -1. Element is heap.get 0, heap.set 0 to that item, heap.remove. Okay, so it's just nudging that up. But Python does that. Python get and remove first item from list. It's the slicing. Pop 0. Yes, that's just pop. So that should just be, unless I'm missing something obvious, I think I'm just going to do a pop. Swap the last item in for the first. Heap.size -1. Oh, okay, no. Heap.get 0. Okay, so we can definitely heap.set. So we set the first item in the list to the last item. Okay. But we can still pop it out. So element is south.heap.pop 0, and then we want to take the last item and now set it to the first. So element heap.get 0, and then it removes it from the end. Okay. So that will then be self.heap dot remove function, which removes the first item from the list, which matches the specified value. Using slicing, short pop, I think. And then, is there a quick way to move something in an array? Python move item within array, within list, not array. Move an item inside a list. List is 1, 2, 3, 4, 5. List plus equals L.pop 0, 2, 3, 4, 5, 1. Okay, so no, but that's not what it's doing. Insert at top of list. Python insert start of list. I'm pretty sure there's a clean way of doing this. And in beginning list. Oh, it's just. Oh, okay, that's easy. So self.insert, and it's going to be south.heap, and that's -1, saying the end of the list. No, hang on. Self.heap -1 is, yeah, it's the end of the list, I think. Python of the list, getting the last element from the list. Some list -1 equals 5. Yeah. Start doubting myself. So, okay, let's just double check that I'm actually doing this correctly. So element equals self.heap.pop. Actually, it probably will do this because we'll say if len self.heap is 0, then just return none. But otherwise, the element we're deleting is the first item in the list, and then we're taking the last element in the list and putting it at the front, I think. Oh, and then it says then you run heapify on the heap. Okay, right. So we'll have to figure out how that works. So heapify. What does heapify take? Heapify takes the index and the size. Okay, right. Okay. Where was I? Remove. There we go. So we'll say 0 and then len self.heap. Return element def size self. Return len self.heap. Let's document that. So get the number of items in the priority queue, returns the number of elements in the priority queue. Doubt most people would actually, yeah, you probably would use this. Peak. Okay, return the next element to be returned by remove. Okay, yeah, so you just do def peak self. Oh, what have I done? I need to do that. Save a bit of time, copy paste. Yeah, that's easy. And then returns. What does this say? It says returns the highest priority element in the priority queue. Yeah. Basically first in the list. Return self.heap 0. Nice. Is the priority queue empty? Okay, def is empty. Self is the priority queue empty. Return true if and only if the priority queue is empty. That's annoying. Return self.heap equals len self.heap 0. Provide all the results in the priority queue in order. Okay. Def enumerate self. It's really annoying. Keep having that in. I'm definitely noticing I'm spending a lot of my time just writing function definitions instead of actually writing functional code. So we have our saved heap, which just copies our heap. Then we have results, which is in just a new list. Whilst heap is empty, results.add. Whilst heap is not empty, results.add remove. Okay. So we have saved heap equals self dot equals new array list heap. Is that making a new heap equals saved heap? Provide all the results in the priority queue in order. return a list of all the results in the priority queue. Okay. Self.heap, I think. Results equals an empty list. While not self dot so I can just say while not self dot is empty. Yeah. Wait. While not. Yeah. Results dot add self dot remove. Then we do heap self dot heap equals save heap, and then we say return results. Right, that makes sense. Def add all. Going to pass a collection of something. And add the elements of a collection to the priority queue. Okay. Just going to say collection. Okay. Presumably that's what that meant. So then for element within the collection, insert it into that. So say for item in collection, self.insert item. Nice and easy. Now we get to heapify. Okay. So def heapify self index
5-minute warning.
Cool, thank you. Size keeps adding that in. That's VS Code for you. Restore a section of the heap to maintain heap properties. Index the point. If the indicated point. Index the point in the heap to work on. If the indicated point does not have the proper relation to its descendants, their values are swapped and descendant is then processed recursively. Okay. Don't need that. And copy that as well. Intent that a little bit because that's related. So if size is greater than 0, yeah, left index is index times 2 plus 1. Okay, right. So index times 2 plus 1. Right index equals index times 2 minus plus 2. Okay. Parent equals heap.get parent. Well, heap.get index. Okay, so right. Parent is self.heap and index. Map index is index. So if left index is less than size and the item in left index compared to the parent is greater than 0, then that's that. Okay, so that should all work. Left index greater than size and self.heap.get self.heap left index compare to a thing. No, just say if it is greater than parent, I think, then mat index is equal to left index. If right index is less than size, yeah, less than, yeah, and self.heap right index is self.heap left index, then mat index equals right index. And then we say if max index, oh, is that max index, not mat index? Nearly had a typo in there. That's on me. Max index is not equal to index. Then we're going to say self.heap index is equal to self.heap max index self.heap max index is not going to be the parent, and going to run heapify again, self.heapify max index, and then size. Okay. I think at that point I probably have time. I'll just go through and have a look, just make sure I'm not doing anything silly. Calling self in all the right places. Peak heapify self.heapify parent.heap.append. That didn't need to be there.
You finished the coding under the wire.
Is that it then?
That's the 30 minutes, yes.
Cool. Nice.
Pencils down. As
now.
they used to say. I don't know if they still say that. Yeah, if you could save that file
Yeah.
for safety.
Yeah, cool.
Yeah, very good job. Very good. All right, so now we have the post-task questionnaire followed by the post-study questionnaire.
Cool.
Just in case
Nearly
there
there.
aren't a questionnaire. All right,
Cool.
so
It's P19, wasn't it?
yes, P19.
P19, no AI, and this was priority queue.
Perfect.
Cool. How mentally demanding was the task? I'd say this was a bit higher. How hurried or rushed was the pace of the task? Yeah, I felt a little bit rushed because I knew I didn't have enough time to do what I wanted. How successful you were in accomplishing the task you were asked to do? I think I was probably about right. I don't know. How hard did you have to work to accomplish your level of performance? Yeah, I definitely had to Google a few things. How insecure, discouraged, irritated, stressed, or annoyed with you? Yeah, definitely. That was a little bit harder. I definitely wasn't too sure, questioning myself on quite a few things there. Probably coding under pressure, but please describe your overall approach for how you worked on this task and how you allocated your time across different activities. So it was like 90% was actually 20% reading Java to then basically probably about 60% was literally just copying out the class structure and typing out comments and documentation. Actually not, it's probably more like 50%. 3, Googling for features slash comparable. Yeah, for googling for comparable features, I guess. So that was probably around 10%, and then 20% was 50, 60, 70, 80. Yeah, kind of actually working on code proper. At least that's how it felt like. Properly. To what extent do you feel you understand how the Java implementation of the data structure works? You know what? Little. Why didn't I have an understanding of this structure? So actually, I felt like I understood the majority of the structure. But that heapify section at the end, heapify function was less clear. Understand. And that kind of seems to be the crux of everything. That seems to be. To what extent do you feel you understood the Java language? Yeah, let's say. Wait, did I skip anything? No? Okay.
The no AI questionnaire is a lot shorter because there's not all those questions about the translation.
It's just the baseline, I guess. Is there any other feedback you'd like to share with us about your experience on this task? I'd say no. That was, fairly straightforward. Cool.
Okay. Great. All right. So now it's the compare and contrast questionnaire. Thinking about the experience of doing it either way.
Yeah. All right. P19. Congratulations, you did it. Yeah. How would you compare your experience working on the translation task without AI support versus with AI support? I felt like the AI supported task was a lot, felt like easier to get started on. A lot of the sort of grunt work, e.g. writing the class structure slash basic comments and rough out code was already done, so saved me a lot of time in cleaning it up. I'd say I think I was also able to better understand the task because I'm currently writing more Python, and so seeing the translation helped me understand Java. Yeah. So basically, because I'd seen what its sort of best efforts of converting the Java, it was a bit easier to read the Java, I guess. Beyond code translation, what other kinds of AI support would you desire for working with code? Definitely AI, definitely generating tests. That would be amazing because none of us write tests nearly as much as we should. I'm definitely guilty. What other stuff would be really interesting? I think documentation. I don't know. This feels like an even harder one to do, but for more context, obviously, when you're the developer, it's very easy just to bung a load of code out and move on to the next thing. But the next person who comes along might not actually understand what you were trying to do. If there was a way of explaining that, that'd be really interesting. Let's see if I can put that into words. Documenting actual code so that future developers might be able to understand what was intended. That'd be quite useful. Generating tests. Yeah, I think so. I think trying to think if there's any other things that would be useful to have. Tests are the big one. Documentation. Maybe. I think as well, and I know that IntelliSense kind of does this, but I'm going to write IntelliSense plus plus to kind of say, IntelliSense kind of just looks at what you're typing and gives you the next sort of, what's available for the functional class you're working on. I'm thinking more if you're actually writing code for the first time, can it actually start recommending, if you're working with lists, is it going to start saying, well, you probably want to be doing something with the list maybe? Don't know, for writing, or if you're working with an existing object, maybe it's going to start pulling stuff in for you. Actually, no, if you write, you start building a delete method, delete function, suggests not too sure. That kind of feels quite useful.
Yeah. You wanted to understand what you're doing, and yeah. What's this all about, right? Yeah.
I guess so. But I'm thinking of things
awesome.
like, in Eclipse, you can automatically generate all of your getters and setters, but sometimes things are a bit more complicated than that. So you might want it to, if you started writing a couple of methods that pull in various objects and do things with them, that it might be able to do that as well. I guess that's kind of what I'm thinking. But, cool. Okay. I think that's everything. Next. Okay. There's more here. Yeah. Do you consider yourself a software engineer? Have you used AI or machine learning algorithms as part of your work? Yes. Please explain your use of AI or machine learning algorithms. Writing wrappers around image recognition. YOLO v5 or node red. Have you performed code translation tasks in your work? Probably not. Would you like to participate in future studies of AI supported engineering? If so, yeah, sure. Happy to. It's been quite interesting. Cool.
Wow. Done and ahead of schedule. I can tell you a little bit and answer questions now about the work that we're doing. So there are a lot of AI models being developed for code now.
Okay.
We didn't develop the one that that you were working with there, that's actually from Facebook, and it's pretty much the state of the art in code translation now. Their
Yeah.
transcoder system can go between Java and Python and C++, and maybe one other language, so something else in the same sphere, and it works like a on the same principles as machine translation from natural languages. So
Yeah. It seemed more like natural language translation.
right. So in some sense, it doesn't really know about like what code is or what it's for, but it says, code like this and code like that have a lot in common. They seem to show up in the same places. And it was trained on all the different languages. So it's mapped them all into the same embedding space, if you understand how those languages language translation things work. And then so it's unsupervised training. We're not saying here's the code and here's the translation. Just like here's lots of code in different languages. And then as part of the training process, the last phase of it is it translates code like say from Java to Python and then back to Java. And its error signal is how far off it was from the original code. So it just tries to learn it that way. It's kind of interesting. So, well, there's been models developed to translate, to generate documentation, to generate tests, we're trying to get our hands on some of that. We convert natural language to code. So you sort of just write out what you want and it would, like maybe for like a little, like, move, you swap these two values, that kind of thing, and then it would write the code for that.
Okay.
But there hasn't been much work to evaluate whether these models are actually useful for software engineers. We think, for the most part, software engineers are used to tools that work. Like when you get a bug in your code, your first thought isn't, well, I wonder if the compiler screwed up. Right. I mean, that's happened. It's happened to me, but that's not your go-to assumption, right? That's the last thing you think about.
It's usually this that's caused the issue,
right.
not the
Between the
compiler.
chair and the keyboard, right? So we were interested in whether AI-produced code translations were helpful for people, given that they weren't going to be perfect. We knew that it was going to screw up. In the test cases they did with transcoder, it got up to like, I think it was 87% correct translations if you consider it correct if one of the top 20 attempts at translating worked.
Right. Oh wow. Okay.
Pass the test. So somewhere in those 20 alternatives, there's the right answer. If you're just looking for its top choice, for the right answer, then it's more like 30%.
Gosh. Okay.
Yeah. So that's why in some of these studies we would give multiple translations, not 20. We were doing 5, I think. Because I don't think anybody can wait through 20 versions of that. That would be inhumane. And whether not only would it be helpful, but would software engineers accept that sort of help, or would they say, "I'll do it myself"? So that's part of what we're studying. So, does it make you better at the task, and how do you feel about it afterwards? Because it might make you better, but you hate it and you felt stressed and annoyed. Some people got very upset when they saw that like os.join thing. Like, oh, the thing is stupid, what is it thinking? You had just the level of reaction of, well, that doesn't make any sense. Let me fix that. Right.
Yeah.
But some people, it causes them to doubt everything it does. And a little skepticism is appropriate.
No, definitely.
Yeah, so
it feels like, sorry, no,
you go ahead.
I was just going to say, it feels like it would have been more useful in some ways if you could sort of turn levels of translation on or off. So you could say, just try and translate the overall structure for me and don't do any of the code or something like that.
Just give me a framework to fill in. Oh,
yeah, possibly.
Interesting idea. Right. So we're also building a plugin for VS Code to connect to the translator and try various models, not just translation, but like documentation generation and maybe some other stuff.
Yeah.
Like in place rather than just like handing you a translation. Like you could push a button and get the translation, and there would be more services associated with it. Like maybe if you hovered over a place in the translation, it would highlight the Java that it came from. And also, if there were places that differed in the various translations, like let's say it did the 20, and that set default line, it wasn't really sure about that. It came up with a bunch of maybe 3 or 4 different alternatives that it tried. It would be sort of highlighted, and you could see the alternatives themselves. And so you could sort of say, oh, okay, so I see what it's trying to do, and I see why none of these choices are right, or this choice is right, and I choose it, and it substitutes it in.
Yeah.
So that's what we're working on now. And there'll probably be a follow-up study where we put that in front of people and let them try it out on examples we provide, and maybe even on their own code. Although this thing has limitations. It's not ready for prime time. It's like if you took a file with more than 100 lines, it would probably just fall on its face. So,
right. Okay. Still quite early days for it then.
Yeah, but the slope on the improvements on these things is incredible. So it's like
definitely,
we want to be ready when the next generation comes out that really can translate like realistic code. So that's what we're doing. If you have any questions, I'm happy to talk more about it.
No, I think it's all really interesting. I'd never considered this kind of sort of level of sort of assistance before. So it's interesting to sort of be a part of that and have a test of it. So thank you.
Thank you very much. Thanks for your time. I know this is asking for 2 hours in anybody's day is tough, and it's 2 hours of hard work on your part.
Well, I've had a pretty stressful week, and actually for the end of my Friday afternoon, this has been a pretty fun way to not
good.
day job. So I've quite enjoyed it.
All right. Well, thank you very much. We much appreciate it.
Yeah, no worries. Thank you.
Yeah. We will be sending you some blue points as a small token of our appreciation.
Oh wow! Oh, that's very kind of you. Thank you. I didn't realize that.
Well, I think it was in the call for help, but I don't know. I didn't see it. Anyway, we'll be sending that shortly. All right. So thank you very much, James. Really appreciate it.
No worries, Stephen. It's been good to do this with you. So thank you.
Yeah. Thank you. Bye.
Cool. Cheers. Bye.